All right, so today I'm going to be talking about JavaScript and how it's different from other languages that you might be used to, like PHP. So in the last lecture, on Monday, we talked a bit about what's similar, what's familiar between JavaScript and PHP or Python or Ruby or C or other languages that you're already familiar with. But JavaScript actually has a really unique take on the object model that makes it sort of entirely different than most languages that you're going to deal with. So functions are a sort of underappreciated concept in JavaScript. They are way more powerful than they are in other languages because they can, for one reason, they're able to be set as values. So right here we have var x equals function. And it's a first-class value that can be passed around as an argument. So you don't have to declare function x and just use x in that scope. You can pass the value of x anywhere throughout, as an argument into another function, or you can module export, as David mentioned, in Node. So the next point is that a function is an object in JavaScript. So you can actually set properties as values on a function and just treat it like it's an object. So when you work with jQuery, you know the dollar, and then you pass a selector into it and invoke it as a function. But then you also have $.ajax. And that doesn't sort of make sense if you think of a function just as being something you can invoke or call. But JavaScript allows you to set properties on functions as static properties with just x.someprop, as I pointed out there. The next point, which we're going to go into a little more in depth, is the fact that functions can be treated as classes in JavaScript. So there is the concept of this new operator, which creates a new instance of the function, along with a sort of like class-like body, which comes along with it. And we're going to go into it a little more. It's called the prototype. And it's what makes JavaScript very unique compared to other languages, which are class-based. JavaScript is prototype-based. And then just at the bottom there, function can just be called plainly as we're used to, so that's nothing new. Another thing that's unique is that arrays are actually objects. They're not like they are in PHP where you just create a new array. This is actually shorthand for saying new array. An array is actually a subclass of an object. So that's something different, and I'll go into a little more detail on that. And the debugging capabilities of JavaScript are really unmatched as far as I've seen. This is a screenshot of the Chrome inspector, which we're going to be using for the rest of the presentation today. And to get to this, you just go to File, Developer Tools, and open Chrome Inspector, or you can right-click and click Show Element, I think it is, on an HTML page, or I think it's Command-Option-J. Opens this up. But we'll go into this, and you can actually set breakpoints as you're running through the JavaScript code and sort of evaluate what the local variables are, what the value of this is, and it makes it way easier to debug code. And you don't, this is not constrained to browser-side code, but you can actually run an instance of this Chrome inspector for your server-side code, which is really neat because you can step through line by line as a request comes into your server and see what's happening and play with the variables in the console down here. So as I mentioned, JavaScript is a prototype-based language, which means that there is a set of default values which are sort of hidden for every function in the object.prototype property. So it's sort of a hash of just different default values that when you invoke a function with the new keyword, those are set by default as functions that are available on the instance. So that actually is really efficient for the, it's an efficient way of creating objects memory-wise because the JavaScript runtime only has to keep track of the prototype of the object. It sort of points to that when you create a new instance of a class. And you can also mimic inheritance as is known in class-based languages where you have sort of like a this extends that. You can mimic that in JavaScript through what's called the prototype chain. And we'll see some examples about that. So if your jQuery plugins, actually, they recommend jQuery authors to use $.fn to add functionality to the jQuery library. And we're actually going to jump to so on this page, we have the dollar. I included jQuery. And if you do $. In the console, which I mentioned bringing up through Command-Shift-J, or just going to View, Developer Tools, and going to the Sources tab.
Do you mind Command-plussing a couple times?
Oh, sure. So when I start to type in a variable, it's auto-completed for me what is available there. So I typed in dollar, and I can see, I think Chrome has some built-in $, and $x. So right now I just want dollar, and I put in a dot, and then it shows me all the properties that are available on the jQuery object. But if I do $.prototype, I now see all of the methods that I'm used to using when I have the dollar selector, and then I chain off that with, add class or append or blur or any of the like. Those are all actually on the prototype, which under the hood, the jQuery creates a new instance of itself, and it sort of hides all those details from you. So the point that I was making back over here with the function, they actually hide prototype from you and just alias it to $.fn. So most people actually don't realize that there is a prototype under the hood that's, that you can tap into and add additional functionality to each jQuery instance if you'd like. So the new operator is really sort of difficult to understand at first. When you call a function with new, it's an entirely different way of calling the function as if you just called it plainly. So the new operator creates what is called a new instance of an object, or a new instance of, you can think of the object as a class. And when this happens, the value of this, which you may be familiar with from jQuery, they sort of set this to whatever is convenient at the time. They usually set it to the current DOM node that you're on as you're going through, like each or something like that. This value is supposed to be the value of the instance that you created with new, which includes everything on the prototype chain and all of the methods that you defined as prototype properties. So it depends on how a function is called, what the value of this is. And it's really confusing if you're new to JavaScript, but every function that's called has a this value. So even if you haven't created a new instance of something, this is assumed to be global. Or you can call a function using the call method or the apply method in JavaScript. You can call a function and specify what this should be. So you can make it dynamic, which is really powerful, but also allows you to do things which can be misleading and confusing to other developers if they're not used to the fact. And jQuery, I would argue, makes it even more confusing by making it convenient and setting it to the current DOM node. But the simple rule to remember what the value of this is when you're looking at a function call is what's left of the dot. So if you have an object and it's something dot something is the function that you're calling, then the first value is what the value of this is. So here is a code example where I'm creating a new object literal, which is just the object created with the curly braces, and I'm setting name to Bob, and then I have a sayName method here, so inside this sayName, if I do x.sayName, the value of this is equal to x, because the left of the dot is x. So if I called x.sayName, it would say hello Bob. And then another example where I'm actually assigning x.sayName, the function, to the variable y, which, as I mentioned in JavaScript, you can assign functions to variables whenever you want. It's really flexible that way. But now when I call y, it's lost the context of x. So this is now global. Or if you're in strict mode, I believe it's null or undefined. But so Y is not what you're expecting here. If you're looking at X and you're going to call say name, you're expecting this name is supposed to be Bob. But if you pulled it off the object and called it by itself, this is now global. And that's what I was mentioning. When you see $.this, you often don't think of what's actually going on. But jQuery sort of has their own domain-specific language for dealing with this, and it's not what you're used to in JavaScript. And I point this out because it's really important for writing well-structured, object-oriented code in JavaScript to really have a good understanding and grasp of how this works and how the object model works and how the new operator works. Otherwise, you'll end up with jQuery spaghetti where everything is sort of all over the place and only dealing with the DOM. If you can actually write JavaScript in a more structured fashion, it makes it a lot easier to work with, to sort of separate the concerns of the dealing with the updating the DOM and dealing with the actual logic and code. So let's take a look at a few examples around that. So I have some examples here. So this is just a simple example of using a JavaScript object and adding a few functions to it and then creating sort of like a miniature application. So it's very simple, actually. The only thing that it does is at first it prompts for your name. So I'll say Tim. And then you can change your name to Bob. And that's all this application does. But what I'd like to point out is how it does it. So I have this name generator object, which has a start method, which asks the user for their name by just calling this ask for name, which down here, it does the prompt. If name was not assigned, then it asks for it again by calling this ask for name. And then once it gets the name, it calls this update name. So this then sets the user's name in the h1 tag. And if the name's not set, it throws an error.
Could you zoom in on the text?
Oh, sure. So it sets the user's name in the h1 tag by calling setDisplayName, which sets the HTML in the JS name container. And I'm prefixing all of my HTML with JS selectors just because it's a good habit to get into, just to make it not so confusing when you are using selectors like IDs or classes for both style and for logic in your JavaScript front-end applications. Because if you have different groups of people working on the code base and you have a selector there that the designer decides to change because it doesn't look great, so they want to put in a new class and take out yours, and you're relying on it for JavaScript purposes, then your code breaks. It's good to prefix and sort of like namespace almost the JavaScript related classes or attributes with a prefix of JS. So this is pretty simple, and you can see in all of these cases I'm calling return this at the end. So this is a good habit to get into to give it a valid return value. And ask for name I'm not, because that makes sense that you would get a name back. But what that allows you to do then, if you return this update name, it's returning the value of setDisplayName, which is returning the value of this. And that allows you to sort of chain, as you're used to in jQuery, by returning the value of this each time. This refers to the current object. So you could call this.askForName.setDisplayName, and it would keep the value of this and allow you to have a nice chain there. And then in this second example, all right. OK, so let's go ahead and open up the console and go to my Sources tab. I'll pop this out, actually. So in the Chrome Developer Tools that I mentioned, there is this piece on the right and a you can see this stop sign, although by default it's black. But when you mouse over it, it says don't pause on exceptions. Click to pause on all exceptions. And when you click it again, it turns blue. And now anytime that there's an error thrown in your JavaScript code, it'll stop at that point and allow you to evaluate what's going on. So, and that's a really useful concept I was about to point out. And then if you click again, it turns purple. And this is normally what I keep it in. It only breaks the code when there is an exception that has not been caught. So a lot of times in jQuery, for instance, they do try catches to test whether or not a browser has some sort of capability and continue from there. This is only when there's an error that hasn't been caught in a try catch. So let's try and submit a name that is blank. So I can see that the code has now stopped at the update name method, and I can mouse over name and see it's empty to blank, or it's equal to blank. So if not name, throw new error. And now I can step back through the function call and say, OK, where did this come from? And see what the value of client is. So it has ask for name method, set display name, start update name. And this is just a really useful way. You can see you have all the variables that are available in that scope, as well as the closure variable, so anything that's closed over by this function. And so I can see that what the value of client is and what the value of this is. So this, because we're in jQuery, is equal to the current DOM element. But it's really useful for debugging code to break on errors like this. Another feature of the Chrome inspector is that at any point you can click on the different lines in the row, and it'll break at the places where you have set breakpoints, they're referred to as. So if I click, the line turns blue. So let me continue the execution here. OK, that broke. Now let's set name to Alice and hit submit. So now I can see even before it got to the point of updating everything, it's now stopped right here. So I can see that this name is Alice. And then I can continue. Let me reload the page. All right, so now that it's starting at start again, it has stopped at this line, and I can see that name is currently undefined. Ask for name is which function it is. So that's also often useful if you have functions that are coming from different files or different places in the code. You can see where it is and then jump to that. It'll highlight it. So good to get in the habit of using debugging tools that aren't just console.log. OK. So let's take a look at a second example, which makes more use of prototypes, as I alluded to. So in this example, we're creating a new function called CS. And this is capitalized. So the convention standard in JavaScript is if a function is supposed to be used as a constructor as opposed to just a normal function, you capitalize it. So I have capital CS, and this takes a variable course ID and course title, which I set to this course ID, this course title in the constructor. And then I also set students and lectures as empty arrays. So the reason that OK, so the prototype properties are then defined down here with, so template is just a simple underscore template. An underscore template being a way that you can, similar to the templates that David had mentioned on the server, you can just write a script tag, which is not a JavaScript script, but a text HTML. And what I'm doing with jQuery is, it doesn't keep these open. OK, there we go. With jQuery, it's getting the HTML value of that template and then running through the underscore utility libraries template engine. So the documentation for that is down here under utility template. But basically, you can read a little bit more about it, but it evaluates this string and turns it into a function, which we can then pass data into and call dynamically. The next two methods I have are add student and add lecture. These just add them to the internal arrays that I've set in the constructor, and then the render method. So let's create a new instance of CS called 164, which has this course number 164 and title, and then CS50, which has CS50 and intro to CS1, and then add a few lectures, students, and then call CS50 render. And if I run code, so I'm doing that with eval. You never really want to use eval, but I'm just sort of taking all the JavaScript that's in here and executing it on the fly. It renders into this template these new instances of the CS class, which have the properties. So we've gone through and done add lecture and add student to each. And as I mentioned, because I'm returning this, I can actually chain these add lecture and add student calls, and it'll work just as well. The other feature in JavaScript that is even more useful on the server side, where you really, at any given time, if your application gets bigger, don't know where you are, and it's harder to set these individual breakpoints that I mentioned in the Chrome inspector, is to use the debugger keyword. So it's just D-U-B-G-G-E-R. And when you put a debugger keyword in your code and you have the, there we go, 2 G's. When you put the debugger keyword in your code and you're running a debugger such as the Chrome inspector here or the server-side Chrome inspector, it tells JavaScript to stop execution on that line of code and then allows you to step through the rest of the execution of the code. So if I click run code here, it's now stopping at this debugger line, and I can see, okay, here's the value of CS50, and it's got course title, course ID, it's got no lectures, no students, and then I can step through the whole add lecture. I can see it's pushing on to this lectures, mouse over that, hello world. I can actually, in the console, do this. So this is set to the current object that you're in. This lectures is hello world. And keep stepping through as much as I want. If I don't want to step into a function call, because I know what that's going to do going into add lecture, there's this button right here which says step over the next function call. And so I can go to the point where I'm maybe wondering about something, like for instance, 164 render. So at this point, it's going to be rendered. I can see this template is the compiled template. I can see at this point I should have 2 students and 2 lectures. And then there's the prototype chain that I was referring to. So the default one that comes along with just an object in JavaScript in general. It comes with toString, value of, constructor, and then the ones that I've added on myself with the add lecture, add student, and then the properties that are unique to this instance of the class as it was invoked with the new keyword. So let's do just one more example on this, and then we'll step to some more interesting things on the server side. So let's go ahead and open this last example, which is, let's see, where is the code? Oh, I don't know where this went. Okay, well, we might just skip over this code then, actually. Oh, hold on, I think I missed the style sheet for the code. Okay. So, let's make this a little bigger. In this example, I'm showing a little more on the setting up the prototype chain, so setting up inheritance with JavaScript. So in this case, we have a catalog, which is going to presumably maintain multiple courses. And so a catalog has an add course method, so it checks whether the course that's passed in is an instance of course as invoked with the new keyword. So if you try and send in something different, it'll yell at you. The render method, which will render each of the courses by compiling its template below. And then we have the course, which acts as, in this case, the base class for individual department courses. And instead of setting each of the course.prototype.method or property, I'm using the extend helper in the underscore library to sort of call extend this prototype with all of these properties, which is useful, a little easier to read. And then down here, I'm doing what's known as setting up the prototype chain. So this is actually a little tricky to people at first, and even still, having done this for a while, it's sort of hard to wrap your head around. But don't let that scare you. So I'm setting up an entirely new class object here, CS, and in the constructor, I'm saying course apply this arguments. So arguments is a special value, I guess you could call it, in JavaScript, the keyword, which has all of everything that's passed along as arguments to that function are available with the arguments call, with the arguments keyword. So as I'm calling with course.apply, this is the current context with which CS is being called. So when I invoke it with new, it's the value of CS, and I'm saying call this course method up here. Oh, sorry. Call this course method right here, but set the value of this to be whatever the value of this is right here. So the apply keyword allows you to sort of change the state of this, which is how jQuery is allowed to sort of switch out this on you as you're going through and make it DOM elements instead of the jQuery object. So now I'm going to set a temporary function which will grab the prototype off the course and sort of set it to its prototype, and then set the prototype on the CS function object to a new instance of that. So basically I'm saying, instead, if I down here did cs.prototype equals new course, then it would be calling everything in this constructor function, which I wouldn't necessarily want it to. So all I'm doing is sort of creating almost like a surrogate function which will have the course's prototype on it and sort of mimic the prototype, the course, but without doing everything in the constructor, and set that to the prototype. And then I'm just adding, so the department in this case is computer science for the CS object, and then I have a sort of abridged version of doing that. It doesn't work in IE9, so that's why I wanted to show sort of what this is doing under the hood. But you can set it up in the same way, where econ equals function course apply this arguments, and then say econ.prototype equals object.create course.prototype. So it creates a new object which is just the prototype for the course, and then set the department there. So now let's just go set a debugger here and click run. There we go. So CS164, we can see the prototype chain. We've got the properties which were set in the constructor, so the values of this that were set, and then on the prototype chain for the CS object, it had department computer science set, and then on the underlying prototype chain, we then have all the methods and properties that are unique to the course object, and then we have the base object. So that's sort of a quick example of the prototype chain. And as you can see here, there are two values for department. So there's department computer science and then department not listed, which I set as the default value here. So the prototype chain is actually just a singly linked list. And as it tries to find a property, it'll start at the top level value, so what's defined in the constructor function, and then sort of go down the prototype chain from there. So because it found, so if right here I say cs50.department, it'll say computer science. But if I say var but if I say humanities equals new course, and then I say humanities dot department, I'll see department not listed because it went to first I can look at the prototype chain here actually. So it went first to the course object and saw there's nothing on the prototype chain at this level for the department or for the department value. So then it jumps to the next level, the course, and looks for it there and finds it. So it just sort of like goes down from the top down, and that's sort of something that's unique about JavaScript is that you can change any of these values at any given time. So in the constructor or in an individual method on the object, if I want to set this department to something new, or if I even want to set any of these functions that already exist to something new, I'm free to do that. So right now I have cs50.addLecture. Looks like that. And if I want to set it to cs50.addLecture just equals to blank function, then now I can see it's just completely changed, which you're not able to do in other languages where you have a stricter class-based inheritance and everything is sort of set up. JavaScript is very, very flexible with regards to that. OK, let's jump back into the slides. So if, for instance, you would always like a function to have a particular this value set for it, you can call function.bind and set what the value of this should be. You can think of it as, I'm trying to think of a good real-world example, but if you want to protect your code against somebody potentially calling it with a value that wouldn't be this, like, for example, an AJAX callback, like success or error, those are typically not called with a good semantic value of this. And you're like, OK, I always want this to be the value of the course object that I'm working with, or the view which I'm working with in my code that represents this DOM node. You can bind context to this, and then when it's called later by jQuery, and it doesn't have a good value of this, it'll stick to what you bound it with. Then there's function call, where you can specify the context and specify any variable number of arguments. And then there's function apply, which you can pass in the context, and then either an array or the arguments object that I'd mentioned, as you see there. And the arguments, in any function that you call, you can just type in the word arguments, and it'll have all the arguments. It has a length property, which is how many arguments were actually passed to that method, since in JavaScript you can sort of call with variable numbers of arguments. It's useful for saying if this had one argument, then follow this code path. If it had two, you might want to follow another way. It allows you to have really dynamic APIs for your methods. You can think of that with jQuery, like when you have $.on or bind, and it sort of does different things as to whether you put one argument or two or three or start it with a function. It is using the arguments property and the arguments length in a lot of cases to have this magic functionality happen. The things you can't do with arguments is use it just by default as an array. So you can't say arguments 3 and set it to something as you could using the array assignment. You can use a lot of the underscore methods for either collections or for working with arrays. You can pass in arguments, and it'll realize that it's an arguments object and sort of take care of that for you. But if you want to use the arguments that are passed to a function as an array, you can use underscore.toArray, one of the number of utility functions that are built into underscore.